Good morning everyone. So today we are going to look at 9 mechanisms, and for this video we will be looking at the first mechanism, which is free radical substitution, and for the type of reaction it is free radical substitution reaction. Before we go into the mechanism free radical substitution, we need to know about the meaning of free radical substitution. So first, what is substitution? Let us have a look at this example. So let's say this one is CH4, methane. When one H is being replaced by one Cl, it forms a new compound called CH3Cl, and this is called substitution, where one atom is replaced by another atom. Next, we need to know about what is free radical actually means. So here we have 2 examples. One is Cl with this dot, another one is Br with this dot. So what does these 2 mean? What is this dot? This dot is actually an unpaired electron. Normally a bond is formed when there is 2 electrons. So when there is only 1 electron, it means that there is no bond formed. So normally we would like to have 2 electrons in order to form bond, in order to become stable. So since these 2 cases has an unpaired electron, so they are unstable. So what they will do, they will want to become more stable. By how? By trying to steal an electron to become stable. So that's why it is a free radical. Another thing that you must take note is that once a free radical is formed, it will continue forming more free radicals. So let's say if you form one free radical Cl with this dot, it will continue to form more until it stops. Next, for free radical substitution, we also need to know about the stability, because there are sometimes it will form one product, but sometimes it will form major product and minor product. So the products form will be based on this stability. So stability is based on the class of free radical. If a free radical is tertiary, it is the most stable, and followed by secondary, primary, and lastly methyl radical. So this one is tertiary, secondary, primary, and this one is methyl radical. So for this one tertiary, you can see here this free radical is attached to 3R, 3 alkyl group. Alkyl group are actually those with CH3, CH2, these are alkyl group. So when this one is attached to 3 alkyl group, it will become a tertiary. Whereas for this one secondary, it is attached to 2 alkyl group. This one is attached to 1, and this one does not attach to any R, does not attach to any alkyl. So this one is methyl radical. So the stability follows tertiary, then secondary, then primary, then lastly methyl radical. Now let's see a few examples for you to learn about free radical substitution. So first, we have CH4 plus Cl2 in the presence of light, which is UV, to form CH3Cl plus HCl. So from this equation, you can see that this is the reactant. This one is the medium, which is in the presence of light, UV. Then this is the product. This is the side product. Normally, the main product that we need will be put in front, and the side product will be put at the back. So for this case, one H is being replaced by Cl to form CH3Cl. Next, we have this one called ethane. When ethane reacts with bromine in the presence of UV in the medium CH2Cl2, it will form CH3CH2Br plus HBr. One H is being replaced by one Br. And this one, 2Br becomes 1Br is replaced by H, become HBr. Next, we have this one called propane. Starting from propane, the product form will not be just one product, but it will form different products because the hydrogen is unidentical. What does it mean? Identical means that all the hydrogen are with the same number. So for this one, when I draw in expanded structure, so you can see that this one is primary, secondary, and this one is primary. So according to the stability, here, according to the stability, secondary will normally be preferred as compared to primary. So this one will be first favored, followed by this. So when this H is being replaced by Cl, it will form this major product. Whereas when this H is being replaced by Cl, it will form minor product. And also this the side product. Lastly, we have this one. When it reacts with bromine in the presence of UV light under the medium CH2Cl2, which is also called as dichloromethane, it will form this one. So you may wonder why it does not have this one as the minor product. Because normally in this, let's say for this question, it has major and minor product even though the hydrogens are unidentical. So the reason is because bromination is highly selective for substitution for tertiary hydrogen. It means that if there is a hydrogen that is tertiary and a hydrogen that is primary, it will select tertiary one because it is more stable, and it will not choose primary, it will not form minor product. However, for Cl2, it is possible and form minor product. So an extra information, why we need to write these things and why we need to write this. What are the difference? Why Cl2 doesn't have this dichloromethane but bromine needs? So the reason is because bromine is less reactive than Cl. This is because according to the periodic table, group 17, the reactivity decreases from high to low. So this is more reactive than this one. Since bromine is less reactive than Cl2, it needs dichloromethane to dissolve and stabilize bromine in order to allow UV light to break the bond and facilitate the free radical substitution reaction. In simple words, Cl, no need, CH2Cl2, but Br need. We need to see about the mechanism now. So first, let us see for this example first. CH4 plus Cl2 in the presence of UV to form CH3Cl plus HCl. So normally in exam, it will ask about the mechanism. How does this form? So in mechanism for free radical substitution, just remember IPT. So I is initiation, P is propagation, and T is termination. So in free radical substitution, we need to remember the aim also. So the aim actually helps you to know what are the steps that you need to do and make sure that you are doing correctly. So whenever you do one step by one step, you take it. Okay, so let's see for the first one, I, which is initiation. So initiation means that you want to start something. So you need to have free radical first, because we need to sub 1H by 1Cl, right? So we need to form the free radical first. So how to form free radical? We need to use this and this one first. When I draw this Cl2, it also can be represented like this. So this one, the bond must break in order to form free radical. So why the bond is not using this arrow but half-headed? Because this one, it is for the movement of electron for two electron, but this one is for one electron. So in free radical substitution only, we use this half-headed arrow. For this one, 2Cl dot is actually Cl dot plus Cl dot, but I write like this. Please note that this is not Cl2 but 2Cl dot. Why we need to use UV? Because UV provide energy for homolytic cleavage to form free radical. Homolytic cleavage means that the things that are identical, let's say Cl2, Br2, are homolytic, and they need to be cleaved for the bond. And this is homolytic cleavage. Next, after you form the free radical, you take one tape, and then next, you need to know that H must be replaced by Cl. So what we need to do is like this. So first, you need to remember that Cl dot free radical, we always try to steal one electron in order to become stable. So it steals one electron from hydrogen in order to become stable, whereas the remaining electron will be directed to this C to form this free radical. So always remember that you want to form free radical from time to time, because free radical will keep on forming. Note that the bond must be shown to show the breaking for this one. Next, after you form this one, have you achieved the aim? H is replaced by Cl. It is not yet right. So you still need to have another Cl in order to actually get the product that you want. So one electron is being transferred to this Cl to form the free radical, and then another electron is projected to here in order to form one bond. So after this, is it 1H is replaced by Cl? Correct, right? So take one thing. So next, we need to also Cl2 become HCl, right? So do we actually get HCl already? So from this, we actually already get this one HCl. So this one aim is also achieved. When all your aim are achieved, please note that you must stop the reaction already. So this is where the third reaction, termination, comes in. When all the aim achieved, all the awkward things will combine, which is all the free radical will combine. So let's say this one, initially we have Cl dot, right? So we need to combine them first. Then it forms Cl2. Next, we have this one, right? This one and this one. So these two will combine together and form this one. And lastly, we have this combine with this one to form this. So it is from here. One more thing, you must always remember that the half-headed arrow must be in opposite direction, meaning that this one and this one is unaccepted because the direction is going to the same direction. It is not accepted, but when the direction is opposite, it is accepted. It's just like when you are having two hands together, it must be two different hands with two different directions in order for you to shake hands. Next, we have the second example. This one react with Br2 in the presence of UV and under dichloromethane, then form this one. So do remember that just now I have said that Br2 is highly selective. It is highly selective for substitution of tertiary hydrogen, meaning that it does not have this minor product. It only forms one product. But Cl2, it will be possible. It will form minor product. So let's see. So we will have three steps: IPT, initiation, propagation, and termination. And our aim will always be the same, either form free radical Cl or Br. For this case is Br, and H is replaced by Br, Br2 become HBr. So always remember, initiation, we need to form the free radical. So one electron from the bond is directed to each Br to form two Br dot. Next, after we form the free radical, we take a tick. Then we will move on to the next step, propagation. Propagation means that you form more and more. It means propagation. Next, we need to replace H by Br, right? Remember that free radical will always try to steal electrons from the others in order to become stable. So the remaining electrons will go to C, this C, to form this free radical. When you form free radical, right? So automatically other steps it will keep forming free radical until it achieves what it wants. It takes what it wants, then it stops. So next, this one, it still doesn't achieve this one, right? So it still needs to go again. So one electron is go to this Br, and one electron goes to this, because this free radical will tries to steal electrons from another molecule to get another electron to become stable. This is stable, and this has actually achieved the aim, which is H become Br. So you can put a tick. Then Br to the HBr, is it achieved already? Yes, it is achieved. So once all the aims are achieved, you can stop by termination. Termination means stop, but in exam you must write termination. So once it wants to stop, all the free radical will combine together to become normal again. So it becomes Br2. So here no need to write H2Cl2 UV, no need, because it is only used in the beginning. Then this one will combine with Br to form this. So these two dots actually will become one bond. Okay. Next, we will have this one combined with this one to form this one. This is two electrons become one bond. Okay. So it will join them together. So all the free radicals are actually from the initiation and propagation steps. Let us see at the third question. So see here. So this one, okay, this is 1-methyl-cyclobutane. When it reacts with Cl2 in the presence of UV, then it will form this product and this product. So you may be first wondering why it doesn't form this one. So it is because the stability, it will prefer a higher stability than a lower. For this case, it is primary. For this case, it is primary, but for this one, it is tertiary because it attached to 1C, 2C, and 3C. So this is actually a C here and it attached to 3C. So this is a tertiary carbon and it is more stable. So always remember IPT, initiation, propagation, and termination. And our aim, form free radical, H replaced by Cl, Cl2 become HCl. So in initiation, bond must be break in order to form free radical. In the presence of UV, always remember. Next, after you form the free radical, take a tick. The next step, we need to replace H to Cl. So, C, the free radical will always try to steal one electron from the others. In this case, this one, this H. So, it will form this one, HCl. It is stable. And next, the remaining electrons will go to here to form this one. So it is not yet finished because the aim is not achieved right. So it will still continue going to get the Cl. So always remember, the free radical will try to steal electrons from the others to become stable. In this case, it will steal from Cl. Then it will form CH3, Cl, then this free radical. So H is replaced by Cl already, so achieved. Then Cl2 becomes HCl, achieved. So once all the aim are achieved, you can stop by using termination. So the unpaired electron will become a bond. Unpaired electron become a bond. Unpaired electron become a bond. So always remember, the bond is half-headed and it must be on opposite direction for them to join together. Lastly, we have the fourth example. So this is its skeletal structure. So this is the equation. So what is the mechanism we form? So mechanism, we always remember IPT, initiation, propagation, and termination. And our aim must be followed one by one. First, we need to form free radical. In initiation, we need to break the bond. Then only we can form free radical, not Br2. Okay, next, after we form the free radical, take a tick. Then it will not take the hydrogen from the other carbon, but will take from this carbon because this is tertiary, but this one is primary. This one is primary and this one is secondary. So it would only take this one for the major product. Remember, free radical will always try to steal electrons from the others. Then the remaining unpaired electron will go to here to form this one. This one is a stable one that is formed from stealing the electrons from H. Then it is not yet achieved because we want H to be replaced by Br. So this unpaired electron will try to steal the electron from Br, and then the remaining unpaired electron will go here. Then it will form this one, and the aim is achieved because H is already replaced by Br, and then HBr is also formed, so aim is achieved. After the aim is achieved, it will come to termination, where all the things are joined together by making the unpaired electrons to become a bond, join together, join together. Electron always comes from lone pair or bond. That's all for this video. Thank you.